Welcome to the CCNA course presented by Smart Tech, Lesson 2, Networking Fundamentals, Part 1. As you know, we will continue with our free CCNA 200-301 training course, which started by Cisco in February 2020. In this video, we will discuss the networking fundamentals and we'll start with the very basic networking concepts, devices, and topologies. To let any person interested or want to start his career in computer networking get a strong background and knowledge starting from the fundamentals. Therefore, the next 3 videos will cover a lot of very basic concepts in details that will help you in your entire successful networking career for at least the next 10 years. Moreover, this video will be a good review for people who are planning to get the CCNA certificate and may have good knowledge of some of these concepts. After that, we will explain the other major subjects and their subs in details in the following videos to build up your knowledge based on strong foundation. So get ready to acquire and learn a lot of information and feel free to contact us if you have any questions. As we have mentioned in our introduction video, we will cover all the CCNA 200-301 certification subjects in details. Some of these videos may cover the full subjects that make you don't require to use the reference book, only to review the subjects and solve some questions. Some other subjects we will explain in details, but will require from you also reading them in the textbook to be engraved in your mind and difficult to forget. We have recommended some valuable books to be as your reference shown in the link below this video, which we think that they are powerful and covering all the required subjects and explained in an easy way. Especially the first reference, CCNA 200-301 Official Certification Guide, Volume 1 and Volume 2. You can buy any one of them by clicking on the links below, which will take you directly to the book page at Amazon. So, let's start our course. Our agenda for today to discuss the following subjects: computer networks, major networking devices, how computer network works, introduction to OSI model and TCP/IP model, what is ISP, what is the throughput, and finally network topologies. And in between, many other subjects will be discussed. What is a computer network? Do you know what are these symbols represent? What are their functions in the network? We will learn all of these concepts in today's video. Now, a computer network is a group of computers and telecommunications devices connected together to share resources or digital information using common telecommunication protocols and technologies. What are the telecommunication devices? This is a router. It is a main device in most computer networks. These are some Cisco routers with different sizes, depends on the size of the network used in, from small office router to carrier operators WAN routers. And here also you can see some small size routers used at home networks. We will discuss all of these router types in details later on in our next slides. Next, this is a switch. It's another important device in any network, different from the router in functionality, but they have some common features similar to each other. This is a firewall. Another networking hardware device, which can be software also, installed on computers. Firewall can be used in a small, medium, and large-sized network to protect them from outside security threats. You may have a firewall installed in your PC, but this hardware firewall is more powerful and have a lot of additional features to protect the whole network from many types of threats. You can see some Cisco models of the firewall. Also, the model selected depends on the network size that we need to use it in. Some of them can be modules, which can be installed on modular type router or modular type switch. Next device is the server. It's the main large powerful PC that provides any service to other people over a local network LAN or over the internet, like google.com, youtube.com, or any other website that provides any service. These servers could be like the servers shown here, or maybe a small PC that has some application installed on it and provide the service to other computers. Finally, the last icon is the client, which is your PC, tab, or iPad, or even your smartphone, that you use it to request any service from a local network, LAN, or over the internet. Let's go more deeply and dig for more details. How all of these devices are working together, connecting to each other in a single network. What are their features and functionalities? How they are used to build the computer network. Let's take a look at the figure shown for PCA and PCB. This is a basic network setup, which consists of two PCs connected together through a cable and the network interface cards, LAN cards, as you can see them here. Can you tell which one of them is the client and which one is the server? The answer is both of them can be clients and both of them can be servers at the same time. Depends on the type of applications installed inside them. So, the server can be defined as the PC that has some application installed inside it. This application provides some service which is needed by other computers connected to this network. So, these computers require to access this application on this server and get the service. The client in this case is the PC that requires some service and have to request it from other remote computer providing this service. Let's take an example to simplify things more. If PCA requests the information about employees' records from HR department application installed in PCB, then PCA will be the client and PCB will be the server. While if PCB requests datasheet file of a specific car, for example BMW, from PCA, and this file was stored in PCA, then PCB becomes the client and PCA becomes the server. Another example is that when you need to connect to your Gmail account and you are located in San Francisco, for example, then first you should use your client software installed in your PC, which is in this case your web browser software, Google Chrome, Internet Explorer, or any other browser. After you run your Google Chrome, for example, you need to put the website URL, which is Unified Resource Locator, or simply the address, which is www.gmail.com, and then press enter. In this case, your browser will initiate a connection request to the Gmail server, which may be installed in USA or at any other place in the world. Then the different networking devices, which we will explain a few minutes later, will forward this request until it reaches to the Gmail server in USA. Then the Gmail server will respond back to you by sending the default Gmail page, which is accounts.gmail.com. After that, your web browser will display the content of this page, which requests from you to enter the login credentials, username and password if you have account on Gmail, or to click on other link inside this page to direct you to another web page to create new account. After you enter your credentials details and press enter, Google Chrome will send this information to the Gmail server in USA. Then this server will check your login credentials, and if they are correct, the server will send you back your Gmail account homepage, where you can check your emails, send and receive new emails. This type of communication will continue between the Google Chrome and Google server until you close the connection with the server to go to other service or other website, or you terminate the Google Chrome application. All these communications are happening over the internet as a background process on your PC, which you don't notice. For you as a person who just want to check your email, don't care about these details. But behind these small clicks which you are doing, there are a lot of devices which are connected to each other to forward your request from place to place and even from country to country to give you this service. That's why the internet always represented by cloud symbol, to hide the details which is not important for the normal users to see. Actually, there are a lot of complicated and complex devices and technologies behind this cloud that deliver these services to you. Moreover, as a computer networking engineer, you need to go into how these routers are connected, the technologies and protocols used, and many other details, which we will explain in details in our next videos as part of the CCNA certification subjects. The main device that is responsible of forwarding all these data communication between your PC and the remote server at any place in the world is called router. The internet consists of large number of routers with huge data processing capacities and different types. All these routers are interconnected between each other to construct the internet. So, router is the device used to forward data back and forth between many different computer networks using standard protocols and different interconnection technologies. Let's present now more devices used in the computer networks. The switch is another major device used almost in each computer network. Let's assume you work in a company which has many PCs in its branch located in New York, and many other devices and computers in the other branch located in San Francisco, for example. So how do these computers can communicate to each other? First step, the PCs in each branch should be connected to each other and communicate locally inside each branch. Then, as a second step, both branches may be connected to each other to let their PCs communicate from branch to branch. To connect the PCs locally with each other, we will need a common networking device that has many ports enough to connect each PC or device in the network, in which each port to be connected to a single PC, and then connect the whole LAN in other port of this device to single main connection for the branch with the outside internet link. This device is the switch. The switch is a device that aggregates and connects all the PCs together in one small local area network with their many network interfaces or ports. as shown here, 24 port, 48 port, or even more network interface ports, to enable them to communicate to each other and transfer data between them. So, the switch used to forward the data traffic back and forth between the different PCs and other networking devices with a single LAN. We can also connect any other network device that can provide some service to get the benefits of resource sharing, like network printer, network scanner, Wi-Fi access points, and many other devices. So, as you can see, the PCs of New York branch connected to a switch. Single switch or more switches can be used also inside this LAN, depends on the number of PCs installed in this office and the distances between them. This switch is used to share data resources and services inside the LAN. But to request a service from a server outside this LAN, in San Francisco branch for example, or a website over the internet, then this switch should be connected one of its network interfaces to an external connection. As you can see from the diagram, switch 1 in New York and switch 2 in San Francisco cannot communicate together because both switches should connect to each other first in order to New York and San Francisco branches can communicate together. Both switches should connect to a device which can forward the data traffic between the different networks. This device is called router. Before we proceed explaining the router, let's take a look at some types of the switches. There are many types of switches as you can see here. They are different in their capacity, connection, types, and even the types of interfaces and protocols which they are using. By the way, protocols are set of rules used and followed by the devices to communicate between each other. We will explain the protocols in details a few minutes later in this video. So, switches have the following features. First, provide network connectivity to devices within the same LAN and cannot connect to other LAN. Second, have many network interfaces used to connect the PCs and network devices together. Third, there are many types of switches like managed, unmanaged, layer 2 or layer 3 switches. Managed switch is a switch that can allow some basic configuration to be done by the network engineer and enable some features as per his network design requirements. Unmanaged switch is a switch which comes from the manufacturer with its default settings and cannot be configured, or it doesn't allow to change any setting or feature inside it. Layer 2 and Layer 3, we will discuss these features in details in the next videos when we explain the networking layers and protocols. Now, let's go back to our network example. In order to connect the two LANs in the New York and San Francisco branches to each other, we have two options. Option 1. Lay a private cable from the New York office to San Francisco office. Wow! One company have to invest in laying cables for a distance of thousands of kilometers, along with their related equipment and expensive technology just to connect their offices together. This is too much. And what shall this company do if it has 50 other branches in different states? This is for sure not the right solution, as implementation cost is very huge and also require permissions to dig and lay the cables inside and between the different cities and states. Option 2. Connecting switch 1 to the R1 router 1 in New York office and connect router 1 to the New York ISP. Also connecting the switch 2 to router 2 in San Francisco branch. Then connect router 2 to the San Francisco ISP. In this case, R1 and R2 will be connected virtually together through the ISPs in each city. By the way, ISP means Internet Service Provider. This is a practical and cost-effective solution to connect both remote sites together. Let's jump to other related subjects. What does the Internet Cloud symbol mean? The cloud represents a huge number of routers interconnected to each other, distributed in different cities in the world to provide networking connectivity between different networks around the world and deliver data traffic from one place to another, as you can see here. We will stop here for today to give you a chance to review the information given today. And please don't forget to subscribe to our channel or click on like if you find the information given today were useful. Goodbye and take care, future CCNA engineers.